The last two sections we discussed about two types of first order differential equations. The first type is variable separable. The second type is differential equation which are reducible to variable separable form, that is homogeneous equation, and other types of reducible to variable separable form differential equation. Now, we are discussing about a differential equation which is also first order differential equation known by the name exact differential equation. What is meant by an exact differential equation? Usually, family of curves are represented by the equation f of x y is equal to c. What is meant by family of curves? A simple example is, consider the equation y is equal to m x. When m is equal to 1, we have the equation y is equal to x, which is a member of this family, y is equal to m x. When m is equal to 2, we obtain another equation y is equal to 2x, which is another member of this family, y is equal to m x. So, we know that y is equal to x is represented as a straight line passing through the origin. Y is equal to 2x is also a straight line through the origin. So, these are all represent family of lines through passing through the origin. So, f of x y is equal to c represent a family of curves. If you differentiate this, this become df, which is equal to 0. Two variables are there. This df means partial df by dx plus partial df by dy, which is equal to 0. Based on this, we define what is the general form of an exact differential equation. A differential equation of the form m x y dx plus n x y dy equals 0 is said to be an exact differential equation if partial dm by dy is the same as partial dn by dx. M is the coefficient of dx, n the coefficient of dy, and we differentiate m with respect to y, not with respect to x, and we differentiate n with respect to x. Whenever these two are equal, this differential equation is said to be exact. So, in a differential equation mxy dx plus nxy dy is equal to 0 is said to be exact if partial dm by dy is equal to partial dn by dx. An example, consider this differential equation e raised to y dx plus x e raised to y plus 2y dy equals 0. E raised to y dx plus x e raised to y plus 2y dy equals 0. Here the value of m is e raised to y, and we differentiate this with respect to y. So, that is same as e raised to y. The value of n is x into e raised to y plus 2y, and we differentiate this with respect to x. What is the derivative of this partially with respect to x means taking the other terms as a constant. So, e raised to y is a constant and the derivative of x is 1, and 2y is also a constant. We are differentiating partially with respect to x. So, this is e raised to y. In this case, partial dm by dy, partial dn by dx are equal, both are equal. So, the given differential equation is exact. So, this is the way to check whether the differential equation is exact or not. The method is, we differentiate the terms which containing dx with respect to y partially. We differentiate the term which contains dy, differentiate it partially with respect to x. Whenever these two partial derivatives are equal, then this differential equation is exact. Whenever a differential equation is exact, how can we solve this differential equation? How can we solve a exact differential equation? In order to find the solution, we have step 1, we integrate m with respect to x, keeping y as a constant. That is the first step. We integrate m with respect to x. This is the given equation mxy dx plus nxy dy equals 0. This is the given differential equation. The first method, first of all we have to check whether it is exact or not. If it is exact, we have to find the solution by this method. The first step is integrate this m with respect to x, keeping y as a constant. The second step is integrate with respect to y those terms in n which do not involve x. Integrate those terms in n with respect to y which do not involve x. Integrate n with respect to y, but the terms are which do not involve x. Those terms which do not involve x, we have to find that particular terms and integrate that terms with respect to y. Then the last step, just find the sum of these two steps and equate this to a constant. That is the solution of the differential equation. So once again, this is an exact differential equation. First of all, we have to find whether the differential equation is exact by checking partial dm by dy and partial dn by dx, both are equal, then it is exact. If it is exact, how can we find the solution? The first step is integrate m, the term containing dx, with respect to x, keeping y as a constant. Similar as partial differentiation, here we integrate partially with respect to x, keeping y as a constant. The second step is integrate with respect to y, not all the terms in n, those terms in n which do not involve in x. Integrate with respect to y those terms in n which do not involve x. Then find the sum of those two and equate this to a constant c. This is the solution of the exact differential equation. Now we go through certain examples how to solve an exact differential equation. The first example is 1 plus 4xy plus 2y square dx plus 1 plus 4xy plus 2x square dy equals 0. The general form is m dx plus n dy equals 0. We have to find partial dm by dy and partial dn by dx. If these two are equal, then the equation is exact. Then we integrate m with respect to x, keeping y as a constant. We integrate m with respect to x, keeping y as a constant, plus we integrate those terms in n which do not x with respect to y, then equate to constant, that is the solution. So, the value of m here is 1 plus 4 xy plus 2y square, m the term containing dx. We differentiate m partially with respect to y. Differentiating this partially with respect to y means keeping the other terms as constant. So, derivative of 1 is 0 and we are differentiating this partially with respect to y means 4 is a constant, x is a constant. So, this becomes 4x, plus we differentiate this partially with respect to y. So, 2y square becomes 4y. Again we differentiate n partially with respect to x. Here the term n is 1 plus 4xy plus 2x square. So, differentiating n partially with respect to x. So, 1 is a constant, its derivative is 0, 4xy differentiating partially become 4y, derivative of x is 1, and 2x square differentiating partially with respect to x become 4x. So, check these two are equal, partial dm by dy and dn by dx are equal, then this equation is exact. So, whenever these two partial derivatives are equal, that equation is exact. Now, we have to find the solution of this equation. We have to find the solution of this equation after they are exact. If they are not exact, there is another method. by finding integrating factor that we discuss in our next class. So, here we considering only x-side differential equation. So, how can we find the solution? The solution, first of all, we integrate m with respect to x, keeping y as a constant. So, integrate this m 1 plus 4 x y plus 2 y square with respect to x, keeping y as a constant. So, what is the integral of this when y is a constant? So, 1 is a constant, we integrating that with x. Here 4 is a constant, y is a constant. So, 4 y is a constant. So, the integral of x is x square by 2. Here 2 y square, both are constant, 2 is a constant, y is a constant. So, integral of dx is 2 y square into x. This is the first one, simplifying this by x plus 2 x square y plus 2 x y square. This is the first step. Integrate m with respect to x, keeping y as a constant. This is m term. We are integrating this m with respect to x, keeping y as a constant. So, integrating 1 with respect to x, that becomes x. Integrating 4 x y with respect to x, 4 is a constant, y is a constant, and integral of x is x square by 2. 2 y square, 2 is a constant, y square is a constant, and integrating x, that becomes 2 y square x. This is the first part. Here we integrate m with respect to x, keeping y as a constant. Now, the second step, we integrate n, those terms in n which do not involve n with respect to y. So, this is the n term. We have to find those terms in n which do not involve x. Here x is here and here also x. So, the only one term not involving x is 1. So, integrate this n 1 with respect to y. So, that become y. Listen once again, the second part is we have to integrate those terms in n which do not involve x with respect to y. Integrating those terms in n which do not involve x with respect to y. So, this is the nth term 1 plus 4 x y plus 2 x square. We have to consider those terms in this n which do not involve x. So, here is x and there also x. The only one term which do not involve x is 1. So, we integrate 1 with respect to y. So, answer is y. This is the second step. Now, after finding these two, we just find the sum and equate this to a c, that is the solution. So, the solution is, this is the first term x plus 2 x square y plus 2 x y square plus the second y and equate this to a constant c. This is the solution of the x-side differential equation, and this is the method for finding the solution of the x-side differential equation. Another example, solve a differential equation. Whenever a differential equation is given, we have to find whether it is variable separable, homogeneous or exact. So, another example, how to solve this equation, sin x tan y plus 1 dx plus cos x secant square y dy equals 0, sin x tan y plus 1 dx plus cos x secant square y dy. We have this general form m dx plus n dy equals 0. M term here is sin x into tan y plus 1. N term is cos x secant square y. In order to check whether this equation is exact, we have to differentiate m with respect to y, keeping x as a constant, and we differentiate n with respect to x, keeping y as a constant. So, we differentiate this m partially with respect to y. What is the derivative of this? Partially with respect to y. Partially with respect to y means the x terms are constant. So, sin x is a constant and the derivative of tan y is secant square y, and y is already a constant. So, its derivative is 0. Again we differentiate n with respect to x, partially with respect to x. Partially with respect to x means keeping y as a constant. So, secant square y is a constant, and the derivative of cos x, we have the derivative of the cos x is equal to minus sin x. Derivative of the cos x is equal to minus sin x. So, this become sin x tan y plus 1. So, this equation is not exact even though sin x and secant square y is there, but here it is minus. So, because of this minus sign these two are not exact. We can make it exact by giving a minus sign here, or we take the entire term the other side. Then the value of n is equal to minus cos x secant square y, and the derivative of minus cos x is derivative of minus cos x is cos x, the derivative is minus sin x. So, minus cos x the derivative sin x. So, these two become exact equation. So, when it is exact, what is the next procedure? We have to find the solution. How we find the solution? We integrate m, this is m, with respect to x, keeping y as a constant. So, keep m with respect to x, keeping y as a constant. So, sin x tan y plus 1 with respect to x, keeping y as a constant. So, tan y is a constant, and the derivative of sin x is minus, sorry, integral of sin x is minus cos x plus integral of 1 is x. We integrate m with respect to x, keeping y as a constant. So, tan y is a constant, so tan y into integral of sin x. Integral of sin x is minus cos x, and the integral of 1 is x. We are differentiating with respect to x. Now, the second part, we have to integrate n, not the entire term in n, those terms which do not involve in x. So, there is only one term and that term contains x term. So, the derivative of n is nothing there. So, the derivative is equal to 0, there is no term. So, this derivative is 0. So, the solution is minus tan y cos x plus x is equal to c. This is the solution of the general solution. This is the solution of the exact differential equation. So, this is the method for solving exact equation. We go through one more problem, how to solve an exact differential equation. 2xy cube plus y cos x dx plus 3x square y square plus sin x dy, this is equal to 0. 2xy cube plus y cos x dx plus 3x square y square plus sin x is equal to 0. So, the general form of the exact differential equation is m dx plus n dy equals 0. Here the coefficient of dx, that is m terms, is 2xy cube plus y cos x, and the nth term is 3x square y square plus sin x. In order to check whether this equation is exact, we have to differentiate m partially with respect to y, and we differentiate n partially with respect to x. So, the m term is 2xy cube plus y cos x. We are differentiating this partially with respect to y. Partially with respect to y means we have to find the x terms as a constant. So, what is the derivative of m partially with respect to y? Here 2x is a constant, and the derivative of y cube with respect to y is 3y square, and here cos x is a constant and the derivative of y is equal to 1. So, this becomes 6xy square plus cos x. This is the first partial derivative. Now, we differentiate n with respect to x. What is the derivative of n with respect to x? With respect to x means we have to keep y as a constant. Already 3 is there. So, 3y square is a constant, and we differentiate x square, that is become 2x plus sin x, the derivative is cos x. So, simplifying this become 3xy square plus cos x. So, these two are same, that is the two partial derivatives are equal, that is partial dm by dy is the same as partial dn by dx. So, the given differential equation is exact. So, a differential equation is said to be exact if their partial derivatives are equal. Here the first partial derivative is partial dm by dy, and the second partial derivative is partial dn by dx, both are equal to 6 x y square plus cos x. So, this differential equation is exact. Whenever it is exact, we have to find this general solution. How can we find this general solution? The two steps are there. The first step is we have to integrate m, we already defined that, integrate m with respect to x keeping y as a constant, plus we integrate those terms in n which do not involve x with respect to y. We integrate those terms in n which do not involve x with respect to y and equate the sum to a constant. So, we based on this result we are doing this problem. So, here m is equal to 2 x y cube plus y cos x. We integrate 2 x y cube plus y cos x with respect to x, keeping y as a constant. 2 is a constant, y cube is a constant. So, we have to integrate x, so that becomes x square by 2. Here y is a constant and we integrate cos x, we know that the derivative of cos x is minus. So, the integral of cos x is sin x. So, this is the first part, 2 to cancel, that becomes y cube x square is equal to y sin x. Now, the second part we have to integrate n with respect to y, not the whole entire term, the terms which do not involve x. So, the term which do not involve x, here x square term is there. So, and here also sin x is there. So, no terms is there involving x. So, we integrate n, the derivative become the integral becomes 0 and our answer is x square y cube plus y sin x is equal to c. This is the solution of the exact differential equation. And this is the method for solving an exact differential equation. And that is all about this exact differential equation.